What if I told you 1 plus 1 is equal to 1? Most of you probably think, how did I get into college? Or I probably should go back to kindergarten. But this is a valid statement in Boolean logic. What is Boolean logic? Well, according to an article written by J. Donald Monk and published by Stanford University in 2002 called The Mathematics of Boolean Algebra, Boolean logic is the mathematical expression of logic statements. What does that mean exactly? It's using math equations to solve whether a statement is true or false. I'm currently studying to be a computer engineer, and this is the basis of everything we learn. We even had taken 2 classes solely based on Boolean logic called CSE 335, Digital Logic, and CSE 235, Discrete Mathematics. And I think this is important because it's in things we use every day. How many of us use search engines to research for our project? I'm assuming most of us did. And search engines use Boolean logic to help find and make sure the websites they provide back are the best and pertain most to the topic we searched for. In addition, the computer we run runs code, and this code is based all upon Boolean logic. I think it's important that we need to know how those things work because we use them every day. So first I'll give you a brief history on Boolean logic. Then I'll talk about the symbols and what exactly is Boolean logic. And finally, I'll show them the daily uses in our lives. So Janet Barrett wrote an article for Colorado State University in 2011 called Origins of Boolean Logic. And in this paper, I learned all about where this Boolean logic came from. So Boolean logic has been around for over a century. And in 1847, 2 men by the name of Augustus de Morgan published his work called the Formal Logic, and George Boole published his work called the Mathematical Analysis. Both of these men are the base and started the foundation for Boolean logic. And another couple of decades later, a man named J.C. Peirce came along and built upon the topic that they have already laid down. All 3 of these men are accredited to the concepts of Boolean logic that we use today. So I keep talking about this Boolean logic and these symbols, and although the symbols are not the same as the 1800s, the concepts are exactly the same. So I created a handout for us to look at to explain more in depth what Boolean logic is. So, as you can see, at the very top I talk about basic symbols used in Boolean logic. Well, first, the most important thing is 1 is equal to true in Boolean logic, 0 is equal to false, ampersand is equal to and, plus is equal to or, and exclamation point is equal to not. So now, what do these symbols do actually? Well, we have some examples. So, first example is, we want to know when we can eat spaghetti tonight. And I will eat spaghetti tonight if I have pasta and sauce. So let's look. This tells what if we have pasta. This is a variable that tells us if we have sauce, and then this is the output, if we can actually eat it. So, if we have pasta and we have sauce, we have spaghetti. But if we don't have one of the ingredients, or we don't have either of the ingredients, then we can't have spaghetti. We also can simplify this long expression using just short mathematical terms. As I said before, 1 is equal to true. So true and true makes a statement true, while false and true, or false and false, makes the statement false. So and statements are always true, or are only true if both of the inputs are true. So next is I will go outside if it's sunny or I have an umbrella. So if it's sunny and I have an umbrella, then I'll go outside. If it's not sunny but I do have an umbrella, I'll go outside as well. And if it's sunny or I don't have an umbrella, I'll go outside again. But if it's not sunny and I don't have an umbrella, then I won't go outside. So this connects back to the statement 1 plus 1 equals 1. So in Boolean logic, this would be read as true or true is a true statement. And using or means a statement is true if one or both or either of the inputs are true. And the only time it's false is if both the values are false. Last but not least is not. I have a statement, I will go to the mall if it's not snowing. So if it is snowing, I can't go to the mall. And if it's not snowing, I won't go to the mall. And you can just use this equation by saying not true, which is obviously false, and not false, which is true. So, what do all these symbols mean and how do they apply to anything I do daily? Well, like I said, search engines are one of the biggest people who use Boolean logic. So when you enter something in the computer, it translates it into a logic statement, and it tries to find any website that makes that logic statement true. For example, if I'm doing a research on George Washington, or if I'm doing a project on Washington, the president, not the state. So when I type that in, it goes and finds all the websites pertaining to Washington. And then it keeps all the ones that have the word president in it, but excludes all the ones that have the state in it, because we don't want anything with the state. And then it will give us back all the pertaining articles or websites like that. In addition, or statements are used in search engines, because if we're doing a project on Republicans, another word for Republican is conservative. So if we type Republican or conservative, it will return all articles or websites containing both of the words, one of the words, or either of the words. And it will exclude anything not pertaining to that, which is what we want when we do projects. Well, like I said, search engines are the intermediate between us, the user, and the computer, because the computer doesn't understand anything but Boolean logic. So, to further explain how code in the computer uses Boolean logic, I created a short demo on code. So for those of you who have never used code before, it's very simple. If statements are only executed if the center one, the thing between the parentheses is true. That means the brackets, whatever it says between the brackets, will be printed or executed. So, in addition, code doesn't use the same symbols as we do when we write it out. Code uses ampersand, ampersand for and, pipe, pipe for or, and it still uses the same symbol for not. So for this example, if we have two values, false and false, we want to know which statement is going to print. Well, first we do false and false, which is false, so this statement won't print. Then we do false or false, which is still false, so this statement won't print. And last but not least, we have not false, which makes the statement true, and since the statement's true, we'll print that value off. So let's try it out. So if I compile it, and then after that, I run it, I got the statement I thought, that the last statement was the one that printed out. Obviously, this is a very small example, but if you open up any code on your computer, you're going to see so many if statements, and they all are based on Boolean logic, and that's what makes our computer run. So in conclusion, I briefly explained how Boolean logic was founded by three men, Boole, De Morgan, and Peirce. And then I further explained what the symbols mean, and how symbols that we see every day in math are actually used in logic statements for Boolean logic. And the most important one is 1 is equal to true and 0 is equal to false. In addition, how is it used in our daily life? Well, it's search engines, which use Boolean logic to give us the best results, and computers, which help us run the code, because Boolean logic is all the computer understands. And I think that after listening to my presentation, you should know how this works more in depth, and that next time someone asks you what 1 + 1 is, you now know the correct answer is 1.